All right, class, this video covers page 2 in your lecture note handout for section 3.7 on polynomial inequalities. And so on page 2, we do our first example in solving a polynomial inequality. In this case, we're going to solve the polynomial inequality x times x plus 8 times x minus 1 is less than 0. We're going to find all the real numbers you can put in for x, and the value of the left side will be less than 0. It'll be negative. So there are 4 basic steps in solving any polynomial inequality. In the examples we're going to be working, we're going to go through each of those 4 basic steps. Step number 1 is we're going to find all the real zeros of the factored polynomial. That means we're going to find all the values of x on the left-hand side here that make the left side of the inequality equal to 0. So to do that, right, we set the left side equal to 0, and then we apply the zero product property. Remember, in mathematics, we multiply and divide factors, and so we have 3 factors on the left-hand side. X is a factor, x plus 8 is a factor, x minus 1 is a factor. And so if the product of those 3 factors is equal to 0, one of the factors must equal 0. So either x is equal to 0, or the factor x plus 8 is equal to 0, or the factor x minus 1 is equal to 0. And when we solve these 2 ladder equations for x, we get x is equal to minus 8 and x is equal to 1. So the numbers 0, minus 8, and 1 are the 3 numbers that we can put in for x on the left-hand side, and the left-hand side will equal 0. We now use those 3 numbers to divide up the real number line into intervals. So you can see you got minus 8 is plotted here, 0 is plotted here, 1's plotted here. We have open circles at those 3 numbers because those 3 values of x make the left-hand side up here equal to 0, not less than 0. So minus 8, 0, and 1 are not in our solution set, so we have open circles at those 3 numbers. We then do the test point method. Well, now that these 3 numbers have divided the real number line up into 4 intervals, we then use the test point method to determine whether the values of the polynomial are positive or negative over each interval. So I have a table here with 4 columns. The first column gives each interval. The second column gives the test point for each interval. And the third column gives the value of the polynomial at the test point. And then the fourth column tells us whether the values of the polynomial are going to be positive or negative over that interval. So the first interval up here on the number line goes from minus infinity to minus 8. The next one goes from minus 8 to 0. The third one goes from 0 to 1. And the last one goes from 1 to infinity. Now again, I want to emphasize these are open intervals, right? These are parentheses, not brackets enclosing the intervals, because we already know that at minus 8, 0, and 1, those numbers are not in our solution set. We want to know about the numbers between those numbers. So in the first interval, all values of x less than negative 8. I use minus 9 as my test point. Minus 9 is less than negative 8. And then I put minus 9 into the factored polynomial to see what the value of the polynomial is. Well, in this case, it's minus 90. That's a negative number, a negative value. So that tells me for any value of x less than negative 8 in this interval, the value of the polynomial will be negative. In the second interval, I use minus 1 as a test point. And when I put in minus 1 in for x up here and evaluate, I get 14. So the value of the polynomial was 14 at x equals minus 1. 14 is a positive number. So that tells me any value of x between minus 8 and 0 will result in a positive number for the value of the polynomial. Excuse me. In the third interval, from 0 to 1, I use 0.5 as my test point. When I put in 0.5 in for x up here, the value of the polynomial is negative 2.125. So that tells me for any real number between 0 and 1, put in for x up here, the value of the polynomial will be negative. And then lastly, for the fourth interval, excuse me, where x is greater than 1, from 1 to infinity, I use 2 as a test point. When I put in 2 in for x into the factored polynomial, I got a value of 20 for the value of the polynomial. So that tells me any value of x greater than 1 put in into the factored polynomial up here will result in a value of the factored polynomial will result in a positive value for the factored polynomial. And so that's what the result is over here. Okay? So remember, okay, we can't lose sight of this. We want all the values of x, right, that make the left-hand side up here less than 0. Negative. Okay? So the first interval of values of x make the left-hand side negative, and the third interval make the left-hand side negative or less than 0. So in step 4, right, we write the solution in interval notation. So from the table up above, right, the interval from minus infinity to minus 8 is in our solution set, right? So I've colored in those numbers, and then the interval from 0 to 1 is in our solution set, so I've colored in those numbers. So we see the values of the polynomial are less than 0 or negative if x is less than negative 8, or x is greater than 0 and less than 1. And so we have to write the solution in interval notation. And so for this problem, the solution in interval notation is parentheses minus infinity, comma minus 8, parentheses union 0 to 1 with parentheses.